Nice thing about metal is it takes less software. None. Okay. So you've all seen Waveguide with those pictures of the wavy things and all that, and you all understand Maxwell's equations. So, right? Who doesn't understand Maxwell's equations? Who's lying? All right. So, Waveguide, it's just metal and air. There's no magic materials. There's no unobtainium in it, you know. And the dimensions have been defined longer than some of us have been around. It's lower loss than coax. Nobody here can generate enough power to arc over in a waveguide. Legally or not, we're talking orders of magnitude. The 10 gig waveguide, you used to find everywhere. And if not, most of it's in my barn. And below 10 gigs, well, it's big and heavy and went to China. And above 10 gigs, it's pretty much essential. Coax isn't worth a damn. And it's also rare and expensive. So go see what the people are asking out in the other room, and they're giving you a bargain. So anyway, 2 years ago, this new DB6NT 47 gig came out. In a moment of insanity, I bought one. And notice it's got these little holes in the front. The RF comes out of one of them. Well, actually, two of them. So it's a really neat thing. It's got 30 milliwatts output. So that's up about 30 dB from where we used to be. Noise figures around 5 dB. You know, haven't got a $2 mimic yet, but that's about 30 dB. That's better than it used to be. And it uses WR19 waveguide. Now, for years, you know, I wasn't really going to get to higher frequencies, but when there was a piece really cheap, I'd pick it up. So I got a random assortment of little waveguides. None of them are WR19. Zero. Okay, now, I know you don't have to use that exact size. It also has separate transmit and receive, and I don't have a waveguide relay for that. And I got 2 months to get it on the air. The hell am I going to do? Well, I could go on eBay and waste a lot of money. But maybe I could use separate antennas, maybe 2 horns. And I wrote a paper about these things a while back, and I think it was 6 wavelengths diameter, maybe it's more. But anyway, the diameter was carefully chosen to a piece of scrap aluminum I found. And it looked like it had about 23 dB gain, but 47 gig, you probably want to machine it accurately. So I've been going to the local makerspace. Well, as part of the declining economy in the U.S., a local tool and die company moved their operation to somewhere with cheap labor, maybe in the south, maybe a lot further east. And they donated the small machines to the local trade school. They auctioned off some of the bigger ones, but I was smart enough not to go to the auction. Because you can get something that takes a crane to lift for probably $100. But, so I didn't compound the insanity. So I get to use all this crap for $35 a month. So I've been going there 2 nights a week to play with it, and I hadn't used the CNC lathe before, and I didn't know much about CNC machining, but we've got a guy who's a pretty good machinist, and I convinced him that this would be a fun project, and so we got out the software and drew up the horn and brought the USB stick over to the machine, and there's no USB hole. But there is a keyboard. So I spent several hours punching in the code. Yeah. And then we ran it a few times without any aluminum in. So it saved a few broken tools. Not me. So, well, if I can get this working without breaking the thing, yeah. Here we go.
Then minimize. And then here you go.
Video one. Okay.
I don't think you have audio on the video, do you?
No, it doesn't matter. It's not on the screen, though.
Oh.
No, you just moved the picture off the...
Oh, okay. Here we go.
All right, start it over if you can without... Oh, you got to bring it back on. Okay. There you go. Okay, there it goes. So...
You're asking a lot.
Yeah.
Look, guys, I don't have it on the screen. I'm looking over here trying to find the mouse.
Well...
Give me a break.
We'll go with it. Okay, so...
What's wrong with...
Just... All right. All right. So you're going to watch the whole horn being the whole outside of the horn being done live. And yeah, but real time. And I'm standing here with my hands in my pockets. No F to D, this is a horn.
Well, I mean, what's the illumination angle being made to match?
It's not. This is a horn. Antenna, that's it. You'll see.
Directly, that is the direct emission. It's not illuminating.
I'm illuminating the
Free space.
in free space. With luck, I'm illuminating somebody else's receiver.
Well, at least it's square meters of it.
Now this looks great. The inside's a little bit trickier.
Yeah, the outside's the easy part.
Yeah, that's right. But
You didn't even have to do all this. You just make it look pretty.
no, you got to get the screws into the flange.
No. Just set the compound rest at an angle and run it in. You know, I had to grind a little more in there. I just put it in the spot recently, and I made it all the way through the job in the last cut. But I got that. People will watch, you got a piece of that quarter inch max, and I grind it. I missed the intro, Paul. Is this a CNC lathe, or is this?
Yeah.
Nice.
That's why I said my hands are in my pocket.
Roger that.
Now the next thing you learn is don't reach in and grab it right away.
Are you going back to slides or to the
Yeah,
next
back to
video?
slides.
Okay, you're going to make this complicated.
we're running late, we can skip the other videos. If we can get this going again.
It'll be easier.
Yeah, next slide. Let's see. Oop, we're still back on the video. Okay, so there's the finished horn. You can see it's a nice taper, a little step at the inside. Where do we go? We went the wrong way, of course. There's from the side. So you got to cut away to get the screws in there, Jeff. Yeah.
But I just kind of think, got a nice taper in there.
Yeah. So, and that's what it's illuminating. 2 horns on the thing, and away we go. And that's a breadboard. Literally. Yep.
That is the best of ham improvisation. Yeah.
Right. And I put a transmit LED on too.
How did you get attachment hole, waveguide center?
Oh, come on. The neatest thing about a CNC is you program in where the waveguide holes go, and they all line up.
Yeah, but you gotta center it. So he's talking about after you get the stock in, how did you find center of the hole? Or?
Same way you do with any. You put a wiggler on it and line it up. And center finders. You quickly learn how to use a center finder. Yeah, edge finder, center finder. So, just to show what I didn't do, is this is Ray's, he had a waveguide switch, and he had a bunch of waveguide, and he and Renee bent those waveguides to that shape. You can see up here that, well, maybe doesn't look as good as the factory ones, but it works. And I'm impressed that he could bend all that waveguide without crimping the hell out of it. But I'm not ready to do that.
That wasn't sort of finished.
Oh, okay.
Fill them full of sand when you bent them, or did you just?
Yeah. Okay. And note these flanges. You'll see them again later. So, this is all you need to know for waveguide. You look up in the chart, which size you got. There's the dimensions. If you make it to that, you got waveguide. Waveguide is just where you remove the metal. Flanges, they're standard, except they're round and square ones, and whatever you have is the wrong one. So to make waveguide flanges, you draw one up on the CAD machine, and you go, array, brrr, and then you put it in the machine, and it marches along and cuts them out. And then you all have a tool for making square corners, right?
Yeah, that's a broach.
Well, for some of you it's broach, for the rest of it's a file. Yeah, so here's the milling machine that made the flanges and some other stuff, and it runs around and cuts beautiful curves. That's another thing you have a hard time doing by hand unless you're W1RIL, who actually made a waveguide switch with a drill press and an XY table, just moving it one. Unfortunately, Ken's no longer with us, so the rest of us need one of these. We'll skip the video. So there's some flanges. Notice that one looks like a lot of like the one on Ray's thing, because I gave him a bunch, because if you're somewhere I might work you, I'm happy to help you out. And as I said, there's round and there's square. Well, if you make one of these, here's the round side, there's the square side. You put recessed holes, you screw it to the round one, and then you screw the square one into this, and you get an adapter. I haven't filed that one out yet. So DB6 NT gets about €1 a centimeter for waveguide, or maybe more. Yeah. Plus $35 shipping. Or you can use hobby brass, which is about the same size as WR22 and is $2 a foot. So, yeah, it's probably higher loss and not as strong and not quite as good inside, and it's $1 a foot, you know.
Why would you think it might not, you're just saying it might be higher loss?
Well, it's not precision, it doesn't have a WR number, and
Oh, I see. Mentally, we think it has.
yeah, there's a lot of hams that think it has to have the HP, high-price meatball on the front or you can't use it. So there's a waveguide switch. What I've been doing is 24 gigs, you have fine stuff, but I make one, a big one in WR42 size to prove things out before I start smaller ones. So, oops. So, yeah, we could watch this video. Let's watch one more video. We can find it. He likes to show off his station, doesn't he? I don't see the dish anywhere in this.
Okay, you want video 3, Paul, or video?
Three. We'll skip one in the interest of losing time.
Well, I can if we start up in the right place.
Yeah, that's fine. There you go. Yeah. The quickest way to break a cutter is to leave all the chips in the slot. So, guess how I learned that? What's the second quickest way to? The quickest way is to get the indexing line that goes wham. Okay, back to the show. So, I said I didn't want to bend all that waveguide. Why not just cut it to shape? So, these two match the DB6NT, and guess what goes out there? Yeah. Yeah. So, I haven't got the mechanics all worked out yet, so it's not finished. And you can guess what that is. Yeah. All right. So to test these things, I needed a waveguide to coax transition. So I just cut slot in each half and put holes in one. And that's the simulated pin length and placing. It's not perfect because what the hell, it's an SMA connector at 47 gigs, but it's good enough to measure. So two of them back to back. Yeah, they got a little dB loss, they got a little ripple, but
Well, the blue one, of course, works.
yeah, that's return loss, so. Yeah. So yeah, it's not perfect, but it's the only measurement I can make so far.
You use an SMA connector. That's fascinating that you even got that good. I thought that would have loaded like a mother and just shorted that right out.
Well, as somebody asked at Mud last year, how can you use SMA connectors at 47 gigs? And the answer is, we're hams. So that's what I was doing last year. I made these OE9 PMJ filters. Notice shitloads of holes to tap. Oh, Jeff, for you, there's a company that makes solid silver screws out on the West Coast. You don't have to plate them.
They're for shooting at them. Actually, that might be cheaper to buy them from them than to send a batch out for batch plating.
Sure as hell is.
I'll have to get that.
Yeah. So they were about $1 a piece, but
Who cares?
exactly.
$1 a piece?
And 25 bucks shipping, but still.
It ain't my money.
Exactly. Well, it was my money, but it's still cheaper.
Still cheap.
Yeah.
That'd probably be a $200 lock charge.
Yeah, exactly. And they don't know how to plate electronic anyway, right? So there's the filter milled out, the holes through, carefully sized, and you can look at last year's proceedings if you want all the details, or I guess I put this in DoBus too. So the final comment about these filters is you can buy one of these from DB6NT for 60 euros, and if I'd known that, I never would have made one. Because I've got a lot of hours in those.
This was a mysterious filter design that people couldn't quite figure out, you gotta figure it
Yeah. Yeah, so it was worth learning how it worked. Okay, the next thing you do is another easier way to bend waveguide is got the slot. And, you know, if I wanted a bigger bend, that wouldn't be hard. And E-plane, H-bend, E-bend, whatever you want. What I can't make is a twist. That takes a 5-axis machine, which I don't have. And in these, I chose to cut the slots all into one side because you're aligning in 3 dimensions in this, and that's a bitch. Most things, I just cut 2 identical pieces and polish the inside and bolt them together. And I got some extra pieces because you always start an odd number of pieces. So with luck, you end up with an even number of pairs. Just pass these around, you can open them up, fondle them. You'll notice I leave the surface tooling marks. I don't bother polishing it. When you feel them, you'll say, what marks? Okay, yeah. Here.
You know, go back to that last one. Did it cut that at an angle, or did you have to jig it so that it was flat?
You know what a box of angle plates costs? $10. Yeah. So the vertical angle, I make an even number of degrees so I can slide the angle plate in, and the other one the machine cuts. And you'll notice there's a little nib at the corner because I didn't want to cut into the vise. Yeah, don't cut the vise more than it already is. You want to get between waveguides. Remember, all my pieces are different sizes. We just make a transition. Again, you make the length so it comes out an even number of degrees in one direction and the machine cuts the other. Yeah, waveguide size transitions, all sizes. If these don't work well, I'll make a longer taper, that's all. That's no problem. Horns. These are 47 gig horns. This is, oh, let's pass this one around too. That's a horn I made for a 24 gig beacon, and it's tall but fairly narrow, not as extreme as the one Tom showed, but he only had a picture, he didn't have to machine it. So Kent measured this yesterday, got about a dB more gain than theoretical. Yeah. And then I'd like to be able to measure some things, so I set out to make a directional coupler, and I found this kind in the Waveguide handbook. Got 3 little holes in the crossguide. That looks pretty easy to make. The other kind they have is this one where you're cutting X's. Now there's about 9 dimensions you have to get right, and that's beyond my skills to cut diagonal slots and get them all right. Yeah. No, it's the 2-volume one that says Waveguide Handbook and has a million charts that are totally unattributed and have no more information.
Most of that stuff's from the Rad Lab.
Well, Microwave Journal used to put out a yearly catalog of ads where they stuck some charts into for filler.
Microwave Engineer's Handbook?
Yeah, right.
Catalog of that?
Yeah, and they'd have all these charts and they put them all in a book. So this chart for this says, here's the dimensions. All holes are an 1/8 inch off center line, and you read the diameters from there, and it's courtesy of Gershon J. Wheeler. I could find no publication anywhere for these. But at the time, I could do some simulation. So I simulated the directions. Had pretty much the coupling they specify, but it had about 10 dB of directivity. That's terrible. Which means somebody did some calculations on the back of an envelope and
Nailed it.
no, you got it as right as you could, you know.
It's quick and dirty.
No,
Too quick, a little too dirty.
it's about as good as you're going to get with a pencil, because you can't do it that accurately. So I played with the hole sizes and spacings and found I could get more like 30 plus dB directivity. So I made some and measured it, and turned out that I got the center frequency by accident closer than the simulation did, and I've got about 30 to 40 dB of directivity on this one. So I made a 30 dB coupler and a 40 dB coupler. This is a 40 dB. So if you guys are running high power, there it is. 3 holes that you make by drilling them out slightly undersized, taking a pin gauge and carefully enlarging it with a set of pin gauges till you get them pretty close. And there's a hell of a lot of holes to be tapped in these. And drilling them out, not the critical holes, that was done on the milling machine, but all the other holes have to be either drilled out to tap or clearance. Because I just drilled pilot holes. Where's Skip? There's the tapping machine. Tap away. Yeah. And then before you put the 2 halves together, you want the pieces nice and flat. So you take some real fine grit wet or dry paper and nitrile gloves from Harbor Freight so you don't grind your fingers off. And a granite surface plate. Why? You can buy a 9x12 granite surface plate for about 20 bucks. Yeah. And so you flatten it out and you screw it together, then you go through a lot of solvents to get all the damn grease and grit off, and then you put it together. So, can you do all this? Well, if you can find a makerspace, they're springing up all over. But here's a hint. I get this Home Shop Machinist magazine, and there are thousands of guys out there that have this great machine shop and really don't have anything to do with it, so they make model train engines or something. Or one guy I saw made a rotary engine with 8 weed whacker engines.
Don't worry, the model engine builders laugh at him.
Yeah, right. So if you can find one of these guys and convince them that this would be a cool thing to do, you probably get them to make what you needed. If somebody wanted to make these, if they had a machine shop with time to spare, so the comment on that is those dual band 10 and 24 gig feeds I had years ago, those were made when everybody was hurting and they were happy to run things just to keep their employees occupied. Now they won't even talk to you, unless you want to compete with NASA for prices. But I'd be happy to share my drawings and whatever, G-code files, if somebody wanted to make these things. Or if you had something really interesting to trade, we could talk. And so, more details will eventually be on my webpage, which next time I get it caught up. So, and one more slide, and one more commercial. So, hope to see you in the spring, and more to come. See that? Talk with no PC boards.